Okay, first of all, if you look at the syllabus, lab test 1 is October 1st, right? In about 10 days or so. Let me just briefly talk about it, how you should prepare for that. I'll give you some written documents, like a preparation guide, a little bit later. Okay, October 1st is going to be Monday. Just go to your register lab session. And there will be two parts of the lab test. There will be written questions. There also will be programming questions as well. So for the written questions there, I would say go over the slides that we have gone through so far. Especially today, we're going to do JUnits. We'll make sure we finish that by the end of the class on Monday. Monday, yes. Okay, and whatever we finish next Monday, it will be the end of the coverage for lab test 1. Whatever we cover on Wednesday, it will not be covered. Okay, and there will be also a programming components for your lab test. Part of it will be lab 1. So that's what I said before. If you spend a good amount of time on lab 1, it definitely pays off. And I will give you some practice problem, hopefully no later than end of Friday. I'll give that to you. I also make some solution video for you to go through. It's an interesting problem to solve. Yeah. It's written and programming. Yeah, separate. So which means you can do a little bit of programming for the classes. Meanwhile, there will be maybe some PDF asking you to have some short answers. Yeah, do both. Remember, lab test 1 is 20%. Right? Okay, yeah. But I would say if you follow everything I said in the class, it should be okay. Okay? I'll make it not so surprising to you. Should be no surprise at all. Okay, today, one topic, test-driven developments with JUnits. Back in 1022, we did a fair amount of test-driven developments in the sense that as soon as you're done with your classes, let's say student management system, and bank account, etc., the way you test them is by writing a tester class with the main method, with maybe lines of creating objects, calling methods, and then system out a print line to the console and see what values you get. If you think the values look okay, then you think the test passed, then you're happy with it. Or you simply show on the tablets. But we do deserve a much better way, much more automated and much more systematic way of doing testing for your Java software as your software becomes more and more complicated. So that's the goal by the end of the lecture. Okay? And we're going to, since we're doing Java, so we are using a framework called JUnits. If you do any other programming language like a C# or any OOP or even Python, so they also support their own testing framework. You just got to search for them. But the ideas applies universally. Okay. So now what I would like to do is, since we just talked about exceptions last class, so I would like to also incorporate the concept about exceptions in terms of testing. Let me give you a very intuitive idea. Sometimes when you are testing a method in Java, sometimes, for one case would be you simply want to test to see if the method would do something normally. Let's say if I withdraw some amount from the bank account, it should subtract that particular amount. That's a normal case. On the other hand, option number 2, if I give a withdrawal amount that's negative, in that case, nothing should be done. So you should terminate abnormally. And you can imagine that when you call withdraw in this case with negative amount, it should give you negative amount exception. And this is exactly what we expect to happen. So sometimes you test without expecting exception to happen, but sometimes you do expect them to happen, right? So these are the two cases. We'll see lots of examples like this today, okay, since we learned about exceptions. So let's now just, let's say we are considering a very simple class called counter, but even for that, the code you have to write becomes quite a bit sophisticated. That's why I'll show you lots of example code today, and we have to review the knowledge about exceptions, try and catch, and also throws. Can we just assume we got two exception classes? We got value too large exception, and also we got value too small exception. These two. These are the only two sources of error for our discussion today. Okay? And then remember the catch specify requirement. Let me recap very quickly for you so we are on the same page. But you definitely should review the whole lecture for exceptions. So whenever you call a method that might throw some kind of exception, you got two options there as a caller. You can either specify as part of your signature to say, I can also throw that particular kind of exception. I'm propagating the error to my caller. On the other hand, I can choose to handle the exception right away by using try and catch block. So these are the two options. But for today, you will be mostly seeing the second option here using try and catch. Okay. So let's say approach one. So you can go over them very quickly. Again, just review. Let's say we got a class C1 and method M1 over here might throw some value too small exception, right? In the case where the value is too small, negative. Okay. So M1 might throw exception, may or may not. And then let's say in this case, if under C2 we got M2, okay? And then C1.M1, which means in M2 we are trying to call a method M1, which might throw that exception. So now let's take the specify option, which means we simply say, I don't want to handle that right away. So I throw that exception as well. Okay, that's an easy option. Option number two. Let's say the similar setup, and now I'm trying to call M2 over here, which might throw that exception. I can do try and catch. Okay, it's just a very quick recap of what we did last time. Okay, things will get a little bit more complicated, especially sometimes you want to say, I do expect the exception to happen. Sometimes you say, I don't expect the exception to happen, right? So the code will look similar, but subtly different. Okay, so now let's consider the counter class, very easy implementation. So we learned about final, which means it's a constant. So we got a minimum value and also the maximum value for the counter. Let's say the maximum is simply just 3, and the minimum value is only 0, which means they can only be possible like 4 values for the counter, right? 0, 1, 2, 3. Okay. And for static, I will review them sometime next week. May not be Monday, but maybe Wednesday. But for static, it simply means you do not have to create an object in order to access that. You can simply say counter as a class name dot min value or counter dot max value. That's something we'll review quickly next week. Okay, on the other hand, I will also talk about private versus public a little bit later. I'll delay that discussion there. Private simply means, intuitively, nobody else can call this value attribute from outside this counter class. If you want to get access to the counter value, you have to call this particular public accessor called getValue over here, right? It returns an integer, return a value. And then we also got a constructor here. Initially, the value for the counter is simply the minimum. Start with 0. Okay? Okay, and more to come. And then let's see. Okay, we got exactly what I said. You can go over them. Okay, now here comes the requirements we want to impose on our application. We want to make sure the counter value must always be between its lower bound and upper bounds, which means your counter value should never go below 0 and never go above 3. Okay, that's a requirement, simple requirements. And we will see how the method can be implemented accordingly. Okay, let's now talk about exception scenarios. Let's say we support 2 mutated methods, increments and decrements. Increments add 1 to the counter value. Decrements subtract 1 from the counter value, right? Remember we talked about the 2 kinds of errors there. You should really be able to map which one to which, right? Okay. For example, let's just intuitively, and then we'll see Java code. Let's say you want to increment. Increment might fail sometimes if the current value of the counter already reaches its maximum, which is 3. You should not allow the user to say, I want to increment furthermore to 4. That's disallowed. You should give a value too large exception. Symmetrically, if you want to decrement, when the counter value already reaches its minimum 0, you should not let it happen to -1. Okay, so and in that case, we should throw exception if this such attempt. Okay, let's look at how we implement these methods. Okay, so far nothing new. Okay, so let's say we want to implement the increment method here. Let's say we have a mutator here called increments, and then we say that it might throw value too large exception. Not always, but sometimes. In the case where the current value is exactly equal to the max value, you can see because max value is static, so we can say counter dot max value, right? We don't have to create an object to access that. We say that you cannot really go increment any further because it already reaches the maximum. So we're going to throw new value too large exception, right? Otherwise, we can increment, okay? From 0 to 1, 1 to 2, 2 to 3, but not any further. Any questions so far about this method here? Okay, it's going to be the background for doing test. Symmetrically, we also got a decrement method here, And now we might throw another kind of exception to say if the current value for the counter reaches the minimum, in that case, you should not allow to really decrement the value. In that case, we will throw value to small exception. Otherwise, if it has not reached the minimum, then we can decrement. Okay, so these two methods, very simple. And that's it about the counter class. So we got constructor, we got accessor for get value, and also we got two mutators. So these are the methods we're going to test about. Okay, so these are exactly what I just said, and we might trigger exception. Okay, that means when you try to call these two methods, you have to somehow wrap around your code within try and catch. Okay, as a preview. Okay, let's talk about a test in general. Okay, what is really a test? Basically, there are two important components about a test. One is what your expectation is. The other thing is what your program actually produces. And the third one, actually there's a third component there. The third one is whether these two things, expected and actual, actually match. If they don't match, it's a failure for the test. If they match, it's a success. For example, let's say I create a counter value to begin with. What do I expect the value to be? 0. If it actually produces 0, it's a success. If it actually initializes the counter value to be 1, it's a failure. They don't match. Okay, something like that. You want to somehow reflect such expectation in your test. Okay, we're going to review how you would do it without JUnit test, and then we'll criticize on that quickly, and then we'll go to JUnit test. So you will really appreciate we actually got such a framework for you to do things. Okay, so somehow you have to have some manipulation of your objects, initialize the objects, and call the increment, for example. And then what do you expect? So this part is really important because sometimes it may not be so clear about what you should expect. For example, for lab 1, part 2, about the matrix operation, somehow you're quite lucky because we tell you what the expectations are. We gave you the tests. But realistically, you have to figure out exactly what you expect to happen at each point, after each method. That's something that you have to build up the experience for. Okay, that's one component there. What do you expect? And for example, let's say after initialize the counter objects, and once we say c.increments, we should expect the value to be the minimum plus 1, right, after the increments. And the second component is what's actually produced, right? So up to this point, I expect the counter value to be 1, but is it really the case? It's not necessarily the case. Okay, I can show you later in Eclipse. I will demonstrate to you. Okay, and finally, you want to make sure either they match. In that case, it's a pass. Otherwise, it's a fail. Okay. In the JUnits, if all the tests you have accumulated so far pass, you get a green bar. If any of them actually fail, you get a red. Okay, you want to make sure you always get a green bar. Okay. Any questions until now? We haven't done any tests yet, but I'm just give you some intuition. Okay, so far we ran the tests by using a tester class with the main method, basically from 1022. That's what we did, which is not too bad for smaller scale example, but let's have a look at them. And the code I'm going to show you also can strengthen your understanding about exceptions. So let's go over them. I got quite a number of fragments to show you. Let's say for this first one, testing counter from console version 1. So I'm going to give you two versions, okay? So basically, if you want to develop some console application in order to test, you have to actually enumerate the test cases. Let me just make it simple. Let's say each test case corresponds to a main method, like a new class, okay? Let me just illustrate to you. Okay, so now, let's have a look at this code fragment here. Maybe I can just choose iPad. Okay, so that's the first one. Okay, let's go over them together. And let's see, and then I'll run on Eclipse to show you. Okay, first of all, let's see that over here we got a class called counter tester 1. Okay, that's the very first test case. Okay, and then we have a main method here, so we can execute it as a Java application. So let's see what we're doing here. The first line here, we're simply creating a new counter objects, and then we simply print out to the console what's the initial value for get value. So what do we expect to see? Expecting. In this case, 0, right? So green one means we're expecting to see. But if somehow we run the application in the console, it appears to be something other than 0, that means there's a mismatch. But how do we judge in this case? We judge by our eyes, right? It's not really automatic. It depends on you, okay? And then over here we have, we try to say C dot decrements over here, okay? Let's try to understand this control structure over here, okay? So now, when I say C dot decrements, so what do I expect to happen in this case? Do I expect the decrement to happen successfully, or do I expect something abnormal to happen? Well, if the current value I expect it to be 0, can 0 be further decremented? Apparently it cannot, right? Because we said it should always be between the lower bound and the upper bound. So what I really expect to happen over here is the value to small exception should be thrown at this point, okay? Let's talk about control structure. If it is thrown, that means after this line, it is going to go to the catch block, which will match this value to small exception over here. And if that really happens, what does that mean? That means the exception occur as I expected. So that means that's why I put that message over here to say it is thrown as expected. Okay, so far so good with this branch? Okay, so what happened to this line over here? That's the part you have to spend a little bit more time thinking about. System.out.print line, value to small exception, not thrown as expected. Think about why I put this line over here, right? At that line over there where I do expect the value to small exception to occur, if it did not occur, what does that mean? That means the line would not be interrupted. It will simply continue to the next line. If it continues to the next line, that means it is not something I have expected, right? You can see the logic here, because I do expect the exception to happen, right? So if I do reach this line over here, if I can reach this line, that means the value to small exception did not occur. Okay, so that's how I test. Let's illustrate that very quickly. Okay, now we'll try both cases. Okay, let's go to Eclipse over here. Let's just go to this tester number 1, and the other test cases will be very similar. I'll make this source code available to you today after class. Let's see the first one, counter tester 1. It's exactly what I just said over here. Let's try the normal case. Okay, let me also show you my counter. At the moment, the counter is correct. I will change that to make it incorrect later. Okay, you can see the counter class over here, and then we are trying to decrement over here, and then the decrement to say if the value is equal to minimum, then we should really throw the exception, right? Value to small exception. So now let's try that. At the moment, if I simply try this, everything should be correct, so that means we should print out this line over here, right? Let's try that. So I can simply right-click on tester 1, and then Java application, and then it will simply say value to small exception thrown as expected, right? So this is a success because I do expect that to happen. Okay, so far so good. Now let's see something here. Okay, let me just temporarily modify the implementation for decrements temporarily. Let me just make a comment over here. Okay, ROM implementation. So rather than counter value is minimum value, what about I say I will only do that when it's maximum? Apparently that's wrong, right? Because now if I try to decrement when it is actually 0, 0 is for sure not equal to, 0 equals max value is simply false. So that means I wouldn't go for the exception, right? So that means I will decrement the value to be -1, right? So now what's going to happen here? What's going to happen is when we say C dot decrement over here, it is not going to throw that exception. That means our code will not be interrupted. So that means we'll simply go to this line over here. It will tell you you were expecting this exception to occur, but it did not occur. So it tells you something, right? Okay, let's try that. Oh, of course, every time when you're done with your edits, you want to make sure you save it. Okay? Otherwise, you have this star besides the class name. Okay, let's try that over here. And then you will see that over here. Initial value is 0 and not thrown as expected. Okay? Let me show you one more detail. Let's see the debugger. So you can also try that by yourself. Let me simply just put a breakpoint over here, right before I execute c.decrement, right before that, okay? And then I'll go back to Package Explorer, right-click on the class and say debug as Java application. Okay, let's see what happened. Okay, so it's now the debugger perspective. Let me just, okay. So now let me just organize this a little bit to show you. You can see right now, we are stopping at c.decrement here, right? Right before executing it, okay? So now, if I simply say step over means just execute this line and see what happened. So now, what do you expect to see if I say step over? Should I go to line 12 or should I go to line 14? In this case, 12 or 14. I go to, yeah, you want to say something? 12, yeah. You go to 12 if the exception was not thrown. You go to 14 if it was thrown. But to really confirm your understanding, let me show you one more feature. Rather than saying step over, there's another button here called step into. When I say step into, I can look into the execution for c.decrements. If I go there, I say step into, you can see now I'm in the context for the counter class in the decrement method, right? So now let's see what this value is. You can also see for example, I can go to Window and Show View, and I can go to Expressions. Okay, so now, for example, I can add one expression over here to show you. When I say this value over here is simply 0, initial value. On the other hand, counter the maximum value over here, I can also put the expression. You can put whatever expression you like, that makes sense. It's 3. So 0 equals 3 will give you false, which means you will not throw this exception, right? If I say step over again, it goes to the else branch, right? So 0 will be decremented to -1. So after this, you will see that this value becomes -1, right? It's completely wrong, okay? So now that means when we go outside, you will just go to the next line after decrements. That's how we printed out the error. Okay, so now basically that's about this fragment of code over here. Any questions? Yes.
So you see now that your value is -1.
Yeah.
On your system.out.println, net value, would that change to -1?
It would. Yeah. So of course, this example just for illustration. You can do a little bit further. What you can do is, let's say you can just extend this line over here. Value too small exception was not thrown as expected, and you can say after this you can say plus c dot get value, and it will show you the current value. I'm pretty sure it's -1. Okay. So basically, this tester is good. It tells you it is thrown as expected. It also tells you when it is not thrown as expected. 2 cases. Okay, it's a good tester. Okay. Any question about this? We got many things that are similar. So this is one case where you do not. This is the case you do expect the exception to occur. There might be an opposite case. Okay, but we'll see. Okay, that's test case number 1. Let's have a look at test case number 2. Okay, yeah. Just before that, test case number 2 is a little bit more complicated. Yes. Sure. So thinking this way over here, so the question was, what happened to this E over here? The E over here. You can understand E as a local variable, just for the catch block. So it's a local variable for the catch block only. Basically, it's like this. When we try to call this decrement method here, if the exception was thrown, remember the way we implement that, we say throw new value too small exception. That was anonymous object. However, when the runtime takes that exception object and give that to us, they will simply give them a name, which is called E. So you can actually do something with it in the catch block. Yeah, that's what it means. Okay. Okay, let's see test case number 2. Test case number 2 is interesting. Let me give you a little bit quick intuition. Let's say this is, so I already tested one case where I do expect the value too small exception to occur. I want to test another extreme. I want the value too large exception to be thrown. So what does that mean? I initialize the counter, and then I will do 3 increments to 1, to 2, and then to 3. And then I will do a 4th increment. That one should trigger a value too large exception. However, you can see there's a slight complication over here, right? Let me just write it down over here before I go to the actual code. Once you understand this complication here, things are not so difficult. I initialize the counter C. Initially, if the value should be 0, and then I do increments, increments, and increments. So which means from 0 to 1, 1 to 2, and 2 to 3. And then I do another increment over here, and then I should really expect the value too large exception to be thrown, right? So 4 increments to call. But now, can you see that somehow calling the increment method here for 4 times, they should be treated slightly differently, right? For example, let's say the first increment from 0 to 1, do we expect an exception to be thrown? From 0 to 1, we don't. From 1 to 2, no. 2 to 3, no. But 3 to 4, we do. So that means the logic of wrapping this around in a try and catch block is slightly exactly the opposite. Okay, that's an intuition for you. Let's see exactly how the code looks like. If you understand the issue here, right? Let me just write it down very quickly here. So over here, for these 3 increments, no exception, no value too large exception expected. On the other hand, increment over here, this is expected. So the code for this particular last call to increments will be very similar to what we are seeing here for test number 1. Very similar. But the earlier 3 calls to increments will be exactly the opposite logically. Let's see. Okay? Once you understand the big picture, it's very easy. Okay, first of all, let me identify the 2 try and catch block for you. First, by the way, if you simply try, you might be thinking, well, why don't I simply not to wrap the first 3 calls to increment in the try and catch? You might say, why don't I simply get rid of this and simply just put C dot increment, C dot increment, C dot increment? Would it work? No try and catch for the first 3 increment. Would it compile? You wouldn't even compile, right? Because increments might throw the value too large exception, right? So which means every time you call C dot increments, you have to make sure you handle that. Okay? So that's not an option. Okay? You must wrap it around the try and catch. Okay, like that? Okay, so now the first try and catch is over here. This is the first try and catch block, and this is the second one. Okay, first and second. Let's have a look at the second one. Second one is exactly identical as in terms of the structure as the previous one. The second one simply say we are making, first of all, you can see that right before this try and catch, we are trying to call what's the current value for C from the previous 3 increments. We're expecting this to be 3, which is the maximum already. So now, when it is maximum, I want to call another increments. And I do expect the value too large exception to be occurred, which means if I do go to this catch block, I would say thrown as expected. Otherwise, if after calling this method here, if I can reach to the next line, that means it was not thrown as expected. Okay, follow this so far? So this green part over here is exactly identical to the previous one, just the same. But now let's see how we can negate the logic over here. Okay? Structure is very similar, but the way you think of it is a little bit different. Okay? So now let's see this over here. Again, we have a try and catch block over here. So we have try and catch and C dot increments, C dot increments, C dot increments. We do not expect any exception to be thrown for any one of them, right? So that means if we can reach this catch block over here, is that something we expected? No. So that means if we can reach over here, we don't expect value too large exception to occur. But it did. So that's why in this case, you will simply say, it was thrown unexpectedly. Okay? Any question about this fragment of code over here, right? So over here, you can say that over here, I don't need to put anything because I just expect the increment to be just executed normally, right? So that's kind of the combination of these two blocks over here. Later on, when we teach you JUnit, the logic is exactly identical. It's just that we have a way for you to say, rather than printing something to the console to be observed by your eyes, we can have something that can be run automatically. Just some syntax you gotta learn. But the logic is really the same, okay? If you understand the logic over here, learning JUnit is not difficult, okay? Any question before I move on? Yeah. Oh, yes.
The C.get value in this case, we started at 3. And
Yeah.
you tried to...
Exactly. I see what you mean. So let's say over here, let's say we assume that, well, let's say for now, let's say the correct implementation, right? Correct implementation. So that means at this moment it's 3, right before we try to call the fourth increments. And if the exception was really thrown as expected, that means we never get a chance to increment it further. So it will stay at 3. Yeah, true. And then C.get value at this point would be just 3. Okay?
So the top row, the orange was the incorrect code.
The orange one?
Yeah,
No, the orange one is, no, basically orange and green, they're both important. The orange part is to make sure the first 3 increments can just be executed normally without any exception. But the green one is to make sure the fourth one you're trying to do, it can violate the requirements we talk about.
Okay, so then the first C.get value was 0?
Which one? Yes, that's correct. The first one, yeah. So over here, the C.get value over here is 0, correct. But you will see that when we translate this in JUnit, you can see the one-to-one correspondence. We just somehow have to translate from system.out.println to be some assertion. Okay, that's all we got to do. To say what you expect to be 1, what you expected as 0, is really the case from the program return value. Okay, that's something we'll see. Any questions? Oh, you got a question? Or are you okay? Yes, go ahead.
So if we try the C.increment to run 3 times
Yeah.
with a for loop, would the try and catch work?
Good question. The question was, let's say I don't quite like having to call this 3 times. Let's say, for example, okay, I see exactly. Let me just go a little bit further. What if the maximum value is 1,000? Do you have to put C.increment 1,000 times? I don't think so, right? So that's exactly the valid point. What you could have done was, for this part, I can in some way to save my writing by saying, for example, I can say for integer I is 0, I less than 3, for example, I plus plus. And then over here, I can say C.increments. And this will work because the C.increment is still within the try and catch block. So that will work. Actually, I like the suggestion. Very good. I do have one slide in the end. Sometimes when you do JUnit test, you may have seen that for lab 1, part 1 already. Sometimes you don't have to say each test case is a separate test method. You combine them using a for loop. Okay, that's something I will show you. I do have an example for you. Any other questions about this? Okay. Okay, let's go on to the next one. The next one I would like to show you. Let's just show you a different version. Let's say you may think if every time I have to create a separate class with the main method for a particular test case, it's a bit too much work. I just show you one possibility over here. I'll go through the code with you. So that's a version 2. So these ones, we have gone through them already. So let's say for version 2, what I would do is I create a small console program, which is iterative. It's going to keep it's like a console program. I'll show you exactly. Okay, this one I'll leave that. I'll explain to you very quickly, and then you can play with it. So let's say over here, it's called counter tester 3. Okay, under here, console tester 3. So let's say run as Java application. Okay, let me give you some intuition here. So basically, it's going to interact with me as a user. Enter increments as a command, decrement, or val. If I say val, it tells me the current value is 0, right? If I say increments and then say val again, it tells me 1, right? Increments, val, It's 2. Increments and val. Now it reaches the maximum. If I try again, increments, it tells me value too big. Somehow, value too big is a consequence of catching the value too big exception. I'll show you the code in just a moment. But you can think about how you will write such console application yourself. It's quite interesting to see. Okay, and then I can just to say any word, I can just say exit. Okay, let me show you the code very quickly. So that one is a slight improvement from the previous one. Only one single class to write, which has a single try and catch block, and is iterative, but still is manual. Which means every time, thinking this way, this is only one particular interaction with the console application, right? I'm testing to see if the value too big exception is thrown. If I want to do it again, I might need to start a program again. Just try another manual interaction with the console application. So you can see it's extremely manual. We want to automate this, right? So automation is really one of the motivations for JUnits. Okay, let me just show you the code very quickly. You can get some insight about exception handling as well. Okay, that's version number 2. Okay, let me highlight an important point for you. Okay, let's see over here. Counter tester 3. And then we have main method here. And then we have some scanner input, right? And then we have some command to be read from the user. It can be inc, dec, or it can be value, val. Okay? So now we just create over here, most importantly, we are creating a counter object over here. Okay? That's the counter object we're going to play with inside the program. And then I simply say over here, I have a Boolean attribute, a Boolean variable to control if I should stay within the interaction. Basically, I'm going to stay in the loop as long as the user doesn't want to exit. Okay? So that's why you see a while loop over here. Okay? So now over here, let's see how the try and catch works. First of all, you can see that we do have a call to c.increments. We have c.decrements. And we also get c.getValue over here. So these are the 3 possible methods you can call on a counter object, right? And out of those 3, c.increments and c.decrements might throw some exception. That is why you see the catch over here and the catch over here, right? Just one single catch block, right? That's how you do the multiple catch block, as we said last time. And in the case where value too large exception is thrown and then is caught, then we'll simply print out value too big. That's exactly what you just saw in the console application, right? And then for each one of them, we simply check to see if the command corresponds to which one to call, right? It's very simple console application, but it definitely illustrates if you want to do such thing, you still need try and catch. There's no way around. Any question about this small program here? Okay, it's just a second version for testing your counter. Okay, but so far for both versions, what we're doing is we are just running each test case manually by our hands. Wouldn't that be nice if we can just click on the button to say launch all the test cases, you run it through and tell us either green or red. That's not what we're doing here. That's not. Okay? That's the most criticism about using tester. Questions? Which last step? The else? Okay. The else, you mean you don't understand that part? Okay, sure. Remember over here, let me just highlight that. Remember we have over here a Boolean variable called user wants to continue, right? Initially that's true. And then we say while, as long as user wants to continue remains true, we'll stay in the loop to keep interacting with them. And the user input can be either string for increments, string for decrements, string to value. Anything other than these 3 commands is considered as they want to exit. So that's why we set it to false. As soon as it's false, when you go back here and check it, it's going to be false. So you exit from the loop. Okay, simple trick. Okay, good question. Okay, so I'll talk about state diagram in just a moment. Let's see a little bit more slides. Okay, that's about us. Okay, you can see these are the console application, console interaction with the tester. Yes?
Back to that example you were just showing.
Yep.
How does it know which of the catch blocks to go to?
Good question. How does it know which of the catch block to go to? For example, The short answer is runtime system will decide by themselves correctly. So for example, let's say if the user enters decrement, for example, decrements over here, and then we try to call c.decrements, and at the moment the value is 0. So we're expecting the value too small to be thrown. As soon as the value too small exception is thrown, what Java runtime will do, it will try to match this exception here with each of the catch block to see which one will be caught first. And value too large, no, it cannot be matched. And it's the second one that will match, so it will just go here. Yeah, it's a good question. So at the runtime, you don't have to worry about it. Java will do it for you. Okay? But let me give you a little bit preview. Once we talk about inheritance after the reading week, we're going to revisit how we do the try and catch block. In the context of inheritance, the order that you put the exception for catch is important. But for now, you don't have to worry. I'm just saying that realistically, when inheritance is effective, you have to worry about such issue. But we'll get there after the reading week. Okay, let's now go back to the slides. And okay, now a question for you. So far we have tested two things. Either we try to increment above the maximum, or you try to decrement below the minimum, only two test cases. Do you think that's enough? Do you think after these two test cases, let's say I'm happy with the result, the exception was really thrown as expected for both cases, can I claim right away my counter implementation is correct? Or in general, you're just testing a few boundary cases for your lab submission. Can you claim that you have really done a decent job? I guess you cannot, right? But in this case, what cases are we missing? How many exactly are we missing? So I'm just trying to show you a little bit testing strategy over here, right? Just for the simple counter example. So we have already done two test cases, already two, which means when the counter value is 0, we try to decrement. When the counter value is already 3, and we try to increment. How many more are needed? Can anybody give me a number? How many more? Exactly how many more? Nope, too many. It's a small number, but it's good to figure it out. Okay, that's okay. Let's figure it out together. Okay, so that's why you need some help to draw something to make it formal. Okay, I'll just show you in this simple example. So we can draw something called state diagram to figure that out. Okay, I'll show you exactly what I mean. So when I talk about states over here, state is basically a characterization of your objects. Okay, so it's a characterization of your objects. And how do we characterize each object? By its attributes, right? Now in this case over here, we have a single attribute for the counter, which is value, right? We know that it should be between 0 and 3. How many possibilities do we have for the value? 4. It doesn't really mean you only need 4 test cases, more than that. Let me draw the diagram for you. So let's see this. As soon as I say counter, so arrow is like an action, the programming statement I need to execute. Counter C is assigned to new counter. Okay? As soon as I'm done with this, so what do I get? I get, what's the value for the counter? C dot value will be 0. Okay? We know that overall, it should be between minimum and maximum. So that means 0, 1, 0, 1, 2, and 3. Right? So C dot V can be 1, C dot V can be 2, and C dot V can be 3. Okay, so these are the possible states. Of course, you might argue that realistically, if you got so many attributes and each one of them simply integer or simply just a string, how can you enumerate them out? The answer is no, you cannot, and you don't have to. You just have to somehow decide how you can group the states into relevant ones. But I'll talk a little bit more maybe later. Just for this simple example, at least you should know that you just have to be as careful as possible. Okay, so now we have to talk about how we can move between the states, right? For example, how can we move from here to here. Increments, c dot increments. From here as well, c dot increments. And for here as well, c dot increments. And now if we do c dot increments, we can still do that, but what do we expect? Yeah, value too large exception. Okay, you get the idea, right? Symmetrically, let's say we do from here to here, we can say c dot decrements. From here to here, c dot decrements. And then we have c dot decrements. Do I miss anything? You should be able to decrement once more, right? C dot decrements. And then you would say value too small exception. This is something called state diagram, and if you're taking 2001, that's what you're learning in the first part. Anyway, if you're not learning, don't panic. Just give you one example. So now, what cases have we covered already? Let's see. So we have already covered, let's say over here, we have covered already this one here, right? And we also have covered this one here. How many more? 1, 2, 3, 4, 5, 6. We got 6 more to be complete. Okay, 6 more. Yes, questions? No, not really. Well, thinking this way, it's a good question. The question was, over here, you can see that. Let me just undo this part over here. If I do c dot decrements over here, if I draw it this way, for example, right? If I say c dot decrements, it's not informative enough. That simply means when I say c dot decrements, at this stage, it will simply just remain to be 0, and you can still do further increments from there. But when you say exception, that means you cannot go back to the normal state anymore. So that's a difference. Let me put it this way over here. Let me draw a little bit more carefully over here. Basically, if I put something like this, right, you can imagine that there is just another state over here. I will call that the dead states, which means once you reach that state, program crashed. You cannot really resume back to normal. Okay? And similarly, this is also reaching the dead states. Okay, guys, any question about this example here? It's simple, but hopefully it can give you some intuition about you should really be careful when you design your test cases. It's an art and depends on experience, but I just want to show you some on a simple example. Okay, how about let's go on and see what we can do. We haven't seen any JUnit yet, but I think you already got enough intuition to see JUnits. Okay, so now these are exactly the tabular form for the state diagram I just drew, the same. Okay, so in total we need 8, we have done 2, we need 6 more. Okay, so now let's say if we didn't have JUnits, so what does that mean for tester? You either have to create 6 more tester classes, or you have to run with the application 6 more times. Okay, that's one drawback. But I tell you what's really more severe drawback. Thinking this way. Let's say you test your current counter class, you're happy with everything, you run all the 8 test cases, right? Let's say today I decided that I want to go back to my Java code for the counter. Okay, let me show you exactly my point. Let me go back to Java perspective here. And then I go to the counter class. Okay, I go to my counter class over here. Let's say I want to do the following. I want to modify part of it, for example. I want to modify the maximum value from 3 to 4. So what's the consequence of that? Let me say my question again. It's really important. Let's say I follow exactly the strategy I just talked about. I ran all the 8 test cases on my current counter class. I'm happy with it so far. But now I decided that I want to make some change to my software, which is completely normal. Your software should always be under constant change for any extension or maintenance. So now I decide that for line number 7, I want to change the maximum value, the upper bound, to be 4, something different. So now, what should I do? If I want to test again, right? If I want to test again, that means I need to manually run those 8 test classes was to manually run that console application for 8 times, plus the new test cases, manually. And let's say 2 days from now, I make another change. What should I do? Manually run everything again. You can see what's going on here, right? So this is something called regression testing, which means you should always maintain a set of test cases over there, but every time if you make any slight change to your software, you should rerun all those tests. But if you have to run them manually, you're going to have a hard life, right? So what you should really do instead is by having a way that can run all the test cases automatically. That's exactly why JUnit will be useful. Okay? So far so good? Okay? So it's really important to see the drawbacks by using console application to do your test. But for 1022, that's enough for our purpose. But now since we are now in 2030, we do want to learn something that's much more professional. Okay? We want to automate the way we run the tests, especially when our software is under constant change. Okay, let's go back there and show some slides. And okay, that's exactly what I said. So you don't want to do things just manually, especially for regression testing. Okay? And the principle is every time you introduce a change to your programming text, to your class, you must rerun all your tests. You never know what happened. Even the smallest 1 character change can compromise all the test cases you have run so far. Okay? Okay, let's go on. So why JUnits? Okay, so let's now see JUnits. Okay. So now it's going to automate. That's the #1 advantage for JUnits. You just have to write your test cases one time, just one time. And then every time you want to run all your tests, just run the JUnit test class as JUnit test, and then it will run through it automatically for you. Okay, I'm going to show you some demo in just a moment. So once you get the list of tests, so now there are 2, this is how you can think of it. Remember we talked about caller and callee, right, last time. You can think about JUnits is a very friendly caller for your implementation methods. They are simply going to demonstrate how your methods can be called, and then what the expected values are, and then to compare if the expected values match the return value for your program, because they are like a clients or callers intuitively. Okay, so now there are 2 kinds of test cases you can write, exactly like how we did it for the console application. Let me summarize very quickly. You can either try to call your method in a legal way. Let's say I try to increment the counter when it has not reached the maximum yet. It's a legal way of using the method. On the other hand, you can also try to use it in an illegal way. Let's say I try to increment when the counter already reaches its maximum, in which case I do expect some exception to be thrown. In which case I do have to play with the logic a little bit, like how we did before. Okay? Okay, so that's about just in general. Any question until now? And then we're going to see some JUnit example. Okay? You will see very close correspondence between the JUnit test we did and what we did previously for the console tester. Idea is identical. The only difference is we try to use JUnit test to automate what we did before. Okay, that's a crucial thing. Okay, let's have a look. Okay, so this the next few slides is simply show you how you can create JUnit test from scratch. I'll demonstrate to you on Eclipse. Okay, let's see how we can do it. Okay, let's go back to Eclipse over here, and then I'm going to show you how you can do it. I'll do it from scratch. Okay. First of all, let me also close this just to avoid confusion over here. Okay. I think I need to stop the debugger first. Okay, and then I'll go back. Okay, first of all, let's create a new project. File, new, Java projects. Let's call that example testing counter. I'll make everything available to you, so but you should know how to create it from scratch for your own purpose. Okay, create a project, Java project, and then over here. And then over here, over there, I think I'll just go over some slides. Basically, we won't have a separation of concern by using packages. You can think about packages in Eclipse is like a folders or subfolders in your file system. You don't want to store everything on your desktop, right? You want to have some subfolders. That's how we organize the project. So one possibility is we can have one package called implementation. Everything to do with your software will go into implementation. Everything that has to do with testing go into a tests package, for example. Okay, let's see exactly how we can do this. So now I will show you how to create the package and how you can create JUnit test. And then I'll simply show you in the demo. Okay? So now, if you right-click on the source and say new, and then package. Let's say I want to create a new package called tests. Okay, that's a new package. Under the package, I would like to create a JUnit test. Right-click on the package, and then I can say new, and then rather than just class, I gotta say JUnit test case. Okay, that's something new to you. JUnit test case, and then over here, make sure you choose version 4. That's what we are using for this course. Okay, and then the convention is you start the class name for the JUnit test as a test. I can say test, and just say which class you're testing. Test counter. Okay, and then we'll say finish. And for the very first time, so far we haven't included the JUnit library in our project. So that's why it's prompting you to do it. Okay? Just do it. So basically, you just have to say, I want to perform the following action. Add JUnit 4 library to my build path. Just do it and then say OK. And it's there. Okay? By default, it's going to be in the package tests over here. And then it imports all the necessary packages for you in order to do assertions. You don't have to worry about them. It's done automatically for you. I want you to look at this funny method here. Okay, before I try to execute the test. This is the test they gave to you by default. Okay, I want you to pay attention to line number 9 first. Line number 9 is the most crucial line to include. Every time when you say add test, so this tells you this method here should be treated as a test method for JUnits. If you get rid of line number 9, it is not going to be run as a JUnit test. Always include that. Okay? And now look at line number 10. Always your JUnit test should be a mutator, just void. Okay? Now, line number 11 is an assertion. And we're going to use this actually in our purpose. Okay? Line number 11 is simply say fail, which means by default, we just want to fail, just to show you. Which means this test is not going to pass. Okay, let's see that. And now I'll tell you what the principle is. Let's do a little bit tricky thing to make it pass. Okay, let's say right-click on the JUnit class, and we say run as JUnit test. And then you'll see red bar, which means something's wrong. Okay, at the moment, there's only one single method with the add test tag. But that one there is failing deliberately. Okay, so now, let me tell you the principle. What does it really mean when a test method for JUnit actually fails? It fails if there is an assertion error. Fail is like an assertion error. Or if it actually throws any exception from the method. Let's say, for example, I am expecting some value, let me say this. I'm expecting some value too large exception. But somehow that exception is not thrown, but something else was thrown. In that case, that will also fail the test. Well, we'll see example. Okay? So now you can see that line number 11 is failing the assertion. That's why this test method is considered as a failure. How can we fix it very quickly? Huh? Very easy. Only 2 characters change. Adding 2 characters. You want to see how I do it? Unfail? No, even simpler than that. 1, 2. Comment it out. Well, 2 characters, right? I didn't lie. Only 2 characters. So what does that mean now? That means the test method here does nothing. There's no assertion failure, no exception. It's considered as success. Okay, let's try to run it. Okay, rerun the test and see what happened. Green. One test, and let me make it even more extreme. If you just want to make yourself happy. Test 2. And then if I rerun it, so far, that one I'm not sure why it does not show. Oh, you know what? Make sure your mouse cursor is not pointing to a particular test. Otherwise, you will only run that test. Okay? Let me just put it here. Okay? Rerun it, and let's see what happened. Now I got 2 tests passing. So what's my point here? You can easily fool yourself by having a green bar. So it doesn't really necessarily mean every time you get a green bar, is 100% safe for your software. You can see I can easily get a green bar. I can easily create 1,000 tests like this. I can tell you, oh, I passed 1,000 tests for my counter. It should be correct, right? So that's my point. Okay, good. Let's now just go over the slides. Okay, you can go over these, exactly what I just demonstrated. What I like to do is to show you how to write JUnit test, especially how you can translate the console test that we had before into JUnit test. I'll go for one example or two in very much detail. The rest should be quite easy to follow, okay? But we still have time, so don't worry. Okay, so now basically this is exactly what I said. So every time you want to make sure you include the add test tag, okay? It's really crucial. And then either assertion failure, our example assertion can be fail, it can be assert true, or assert equals. There is another one called assert array equals. That's also very useful. I'll give you more example next week, but let's get the basics understood. Or any unexpected exception. Let's say this. You try to manipulate an array in your test, but somehow you actually try to give an index to the array that's too large. So you get an index out of bound exception. That's unexpected. That will also cause the method to fail. Okay? I'll give you more example. Maybe these are a little bit more advanced example. I'll give them to you next Monday. Okay, let's now, so this slide is pretty much covered. Okay, but the bottom line is you should always get a green bar at least, even though it doesn't guarantee too much. It depends on the quality of your tests. If all your tests are like the one I just generated, that's not a good sign, right? You want to do more analysis before you try to program, okay? Okay, so now let's try to look at the test. Okay, this is exactly what I just demonstrated. Okay, so now what I would like to do, remember this table here, that means in total we need 8. I'm going to translate 3 of them for you. For the rest, your exercise. Okay, so now let's do the green one. Let's say for the green one, we don't expect any exception to be thrown. Okay, and we have to basically create a counter, increment once, and we don't expect any exception to be happening, right? Now, before I do this, I would like to remind you very, very quickly about what we did before for the console tester, because the logic is exactly the same. Okay, you know what? Actually, there's no correspondence from the console tester. Let me just go there directly. Beg your pardon. So let's do this directly on the JUnits. Okay. So now I'll go over the code with you, but you can simply type it out on your computer. I also made the source code available to you. So now you can see that, first of all, do a check for me. Is there any system.out.print line here? No, right? Okay, that's not surprising because we do want to get rid of it. We don't want to rely anything on the console to be checked manually. And then you can see, okay, let me just try to illustrate to you. Once you know about the syntax, it's really straightforward. Let's do this one. First of all, extremely crucial, add test. And then we have a mutator, and now over here we're just trying to give some meaningful name about the test. Usually you should start with the lowercase test, and then whatever I say, test increment after creation. Hopefully that's informative enough for you, right? So now let's see what we got over there. First of all, let's see over here. We got counter C, new counter, okay? And then let me skip the assertion just for now, okay? I'll do that a little bit later. And over here it says C.increments, okay? So these are, and also we got C.get, let's not worry about assertion. So these are the only 2 that's outside the assertion, okay? You can see here the manipulation for the counter is pretty much similar to the console tester. And now let's see the try and catch block. Let's go piece by piece. And over here you can see, because we're calling this method here, which may or may not throw the value too large, exception. So that's why we have try and catch and of the same of the right type. Okay? So now question for you. When I execute this line, do I expect exception to occur or not? In this case, do I expect it to happen or not? That will affect the way you write your test. Anyone? C the increments. At the moment, what should be the value for C after initializing it? 0. Can I increment from 0? Absolutely, yes. So that means I don't expect any assertion to any exception to occur. So that means over here, have a look at this line here. So that's why this is crucial. Let's say after this line, if I do throw the value too large exception, which it might, if it does throw it, it will be caught by this catch block over here. And we know that from the console tester, what would we do in the console tester? We simply system the other print line to say it was thrown unexpectedly. But now in JUnit test, we don't want to do that anymore. We simply say fail. That should be considered as a failure of the test. And then we say exactly the same message as before. Okay. Can you see the transition here? So rather than having an error message to the console, we are having a failure of the assertion of the JUnit test. That's the transition. Okay, that's number one. And then, since we don't expect any exception to be occurred after increments over here, what we can do is, what we did before, we simply say system the outer print line c.getValue, and we will get 1 after increment, right? But here we simply say assert equals. You can think about assert equals is just a method from the JUnit for you to call, right? And here's a convention. Whenever you say assert equals over here, this is something you expect. And this is something that's actually produced by your program. Okay, in this case, you can see 1 is expected on the return value for c.getValue. Okay, any question about this particular assertion over here? Any questions? Okay, and then you can see more. Let me show you again. These 3 assertions are doing exactly the same thing. I just want to show you different flavors of writing them. Okay, let me see the one we are familiar with already. You can say something like assert equals c.getValue is actually produced. I expect that to be the minimum value right after I create a counter. That's one way to do it. Okay, you can expand this assert equals slightly. Okay, by saying I still get assert equals, I still get expected value, I still get the actual value over here. But now I can put something a little bit more. I can put an error message over here, which means if the assertion, this assertion fails, this message will be printed out to the JUnit report. Okay, and one more. So assert equals is expected and actual. You can do it another way. So this is very general. So I'll highlight it here. Assert true. So that means whatever expression you put it there must be true. If it is not true, assertion error. For example, I can translate to say I expect minimum value and from the c.getValue, which means they must be equal, right? So that's why I put an equal in between them. So when I say counter.minimum value equals c.getValue, it should be either true or false. If it is true, that means I got a success for the assertion. Otherwise, it's false, so it's failure. So for these 3 lines over here, they are equivalents. I'm just showing you different ways of writing them. Which one would I recommend? Third one. The third one tells you the message, expected value, and the actual value. The first one is a little briefer. Okay? Any question about this? The first example here, before I go on to the next one. Are we okay? Okay, we have time. Okay, let's go to the test case number 2 over here. So now this is the one I would like to remind you about. Yes, question. Assert equals, yes. Basically, assert equals is going to assert. Okay, thinking this way. When you have an assert method here, it does not return anything, right? You can think about it's more like a mutator. So this is more like a mutator call. Okay, so basically you're trying to check to see if the expected is the same as actual. If they are the same, you simply pass this assertion. It simply doesn't do anything. If you actually didn't pass, in that case, it's going to cause an assertion failure, which will fail the entire test method. Yeah, that's what it does. Okay, let's go on to the next one. Okay, test case 2. Okay, let's now, I want to remind you very quickly here. So this one, we did do it for the console tester. Let me remind you very quickly. So now we want to test to decrements from minimum value. Let's review very quickly. That's exactly what we did for over here, right? That's a counter tester one we did. So we tried to initialize the counter, and then we tried decrements. And then we got a different message over here, right? Right? That's what we did, what we did before. I'll leave the one-to-one correspondence check for you, but you can check to see they are exactly corresponding. But let's not go over the JUnits. If you already understood logic for this tester here, you should have no problem of understanding the JUnits. Okay, let's have a look. So now test 2. Again, crucial to put this tag here, and then mutate the method, starting with test, and give some informative name. Okay, let's see how we can manipulate it. So counter C, initialized, we try to call decrements. So these are the method calls. Okay, so now it's a different way of thinking now. Before, we try to increment when value is 0. We shouldn't expect any exception to be thrown. What about in this case? In this line, when we say C.decrements, do we expect anything to happen? Oh, any exception to be thrown? We do. If the exception is not thrown, what does that mean? That means we can go to the next line. What's the next line? Fail. It's like an error message, right? Okay, hopefully you follow the logic here. Okay, let's go through the two different cases. In the case, I'll give you case 1. I'll try to use different color to give you case 1. So let's say case 1. Let's say value too small exception is indeed thrown. If it is thrown, it will be caught by this branch over here. In which case, we simply do nothing. Do nothing simply means nothing is going to go wrong. The test method will just be considered a success. Otherwise, let's say case number 2. Case number 2, let's say value too small exception was not thrown. If it is not thrown, that means we can go easily from here to here. In this case, we're going to fail because we do expect it to happen, but it did not. Okay. Guys, any questions? This might be the second most complicated one for the lecture. Okay. So my advice for you would be, think about what's the logical idea you're trying to encode. Sometimes you do expect the exception to be thrown, but sometimes you do not. And that is going to affect the way you write it accordingly, right? Because you will see some example where I might put the fail inside the catch, which is the previous case, right? In which case the fail occur over here because we did not expect the exception to be thrown, right? So be careful. So a very sensible question for me in the test, lab test, I'm talking about October 1st. I might give you something like this, but I will swap the place for fail. And then I will ask you to explain to me whether the test case makes sense or not. Okay? I'll give you some exercise over here. Okay? Let's say, let me ask you this. It could be a potential question. Let me say I simply move this line. I will simply put it immediately after C.increments. Is that appropriate? Think about it. Okay. Similarly, I can ask you a similar question. I'm going to move this fail over here into the catch block. Is that appropriate? You might think not, but you gotta be able to explain. Okay, that's my advice for you. Do think about these kind of issue. Okay, one more. Okay, how do we test this case over here? For this one here, I'm gonna give you 2 versions. The first version is gonna work, but the second version demands a little bit of thinking to see why it doesn't work. Okay, let's go through the first version, which works quickly. Okay, over here, test tag, test informative name. We're trying to increment 4 times. Okay, what we did before for tester number 2. Okay, we do 3 increments over here. Remember, for these 3 increments, we do not expect the value too large exception to be thrown. If it did happen, we fail. Okay, logically makes sense. And then we go to assert equals to make sure we reaches the maximum value. Okay, after 3 increments. And now here comes the thing. We say try over here to do the last increments. This case is exactly the opposite, right? For this one, we do expect the increment to throw some exception. That's why if it didn't, we fail. Right? If it does throw the exception, do nothing. So it's considered a success. So the big picture hopefully is clear for you. But you should really make sure you can develop this kind of test from scratch by yourself. It's really important. I have a question for you. You may not feel very comfortable about having the try and catch repeated twice. Since you can see the first catch block, value too large exception. The second catch block is also value too large exception. What about I combine them together? Okay, that's my question for you. Look at this, a single catch block. So basically I got try over here, and then I also got catch, try and catch. It's only a single catch block over here. So I do the 3 increments over here, and then I do the final increments. And I do expect to see the value too large exception to be thrown, right? Something like that. Do you see any issue here? Can I simply just combine them? That's my question. Can you or can you not? If you say we cannot, then what's the issue here? How about I give you a little bit hints? This fail over here is not the issue. This fail here is actually still makes sense, because if increments over here did not throw that exception there, we fail. Okay? What's the issue here? Think about it. I think it's worth thinking. What's wrong here? I can tell you it's wrong, sound line. And it's line number 10. It's also not line number 1. 2 is also okay. 3 is fine. 4 is fine. 5, 6, 7 should be fine, right? Just calling that 3 times, right? 8, yeah, just asserting, right? 8's okay. 9 is fine, calling that 4th time. Well, which line is left? 11. Can somebody tell me what's wrong over here? It compiles, but what's wrong here in line number 11? Logically speaking. Another hint, this test over here can be misleading. How about we try this? I'll give you some further help. Let's say I implemented increment method wrongly. It always throws the value too large exception. No matter what, it just throws. That's the only thing it does. It just throws. In this case, would the test pass or fail? Why would it pass? Tell me exactly how it will work. So I will go for line number 3, initialize the counter. In line number 5, we call the increment for the first time. And then it throws the exception from there unexpectedly in line number 5. Okay, let me write it down on the annotation. It's really important to know. Okay, let's say for this one over here, if I throw value too large exception unexpectedly, what's going to happen here? What's going to be the next? Would it go to line number 6? No. It will go to the catch block. And it says expected, do nothing. Success. On the other hand, let me emphasize my point. Let's say I implemented my increment method correctly. And then, so there's no exception from here, but there was one exception from here. Value too large exception. And in this case, expectedly. And which line would I go to? The same line, right? The catch block, right? You will also go into this one here. So somehow you're trying to fit in 2 branches, which mean complete different thing into one single branch. So do study this very carefully. That's why you cannot simply get around with the 2 try and catch block. This one here is handling something that's different from something here, right? Because in here you do have a fail, but in the other way, you cannot just combine. Okay, any question about the JUnit test? Okay, I think I will finish earlier today. What I will do is I will go through the rest of the details on Monday, but check your Moodle message. I'll give you tips for preparing for the lab test. Friday. I'll send it to you.